in this example, a rancher is building a corral. He wants to make it one big rectangle which has two identical rectangles within it. We see it right here. He has 480 feet of fencing to build the outside of and the border in between the two rectangles. So all the outside and the border in between, 480 feet of fencing. He wants to build the rectangles in such a way as to maximize the amount of area. That makes sense. You want as much area as possible in your corral. So if that's his game plan, how should he build the corral? So this is a very, very practical problem. We're getting sophisticated now in our mathematical abilities so we can solve real-life problems. Now, I don't mean that this is, I mean, it might be something ranchers need, but all kinds of people who are desiring to lay something out in the way that's most spacious possible. And this applies to building boxes for holding things and shipping things and storage containers and silos that hold things and laying out, plans architecturally. All the time, people use this kind of math in the real world. So I enjoy it when it gets more sophisticated like this in real life. All right, so how are we going to do it? Because there's different ways, aren't there? There's all kinds of different ways. For example, we could say, well, we have 480 feet. I don't know, we can make this 100. Well, that's kind of crazy, huh? Maybe we could say, okay, let's make it 50, 50, 50. That'd use up 150. What do we have left there? 330. And then we have to do that in 4 pieces. I don't even know what that would be. By 2, 150, 165. I kind of blew it. I don't know the numbers here. Well, actually, I could do it. It'd be 150 and 165, and half of that would be 82.5. So basically, if you made these 82.5, all 4 of these, if you add all that up, that will be 480 feet, I think. Yeah, I think it is. So that's one way you could build it. Now, how much space will that give you? How much area is right here, and how much area is right here? Well, the total area, this is 50 by 82.5, and this is 50 by 82.5. So if you multiply those, you'll get an area, and you could get a total area. But there's other ways to build it differently. Whoops, I meant to erase all that. There's other ways to build it, and the question is, we want to build it the best way. What is the best way to build it? There's different ways that would produce different areas. In fact, actually, let me go back to that one. What did I say, 82.5? I should have went ahead and shown that. This area of this thing would be 50 times 82.5. Let me use my calculator real quick. I'm getting kind of scribbly, but let me see that. I'm getting 4125. So both of these would be 4125. Total area inside would be 8,250. Now, there's another way to build this thing. You could make it longer and more narrow, kind of, couldn't you? Like that. So, well, that other side didn't come out looking like a rectangle very much, did it? Let me let me try that again. So, kind of like this. So, how about that? Isn't there a way? And then put this in the center. Isn't there another way? Maybe we can make this longer. Make this like 100, 100, 100, 100. Whereas these were all 82.5, 82.5. And that'd be 400. That would leave us 80 left. Divided by 3. I don't know what 80 divided by 3 is. It's 26.7, basically. So this would be 26.7, 26.7, 26.7. That would use up all 480 feet. And what would be the area here? Well, the area would be the 100 times the 26.7, right? It's one side times the other. So that would be 2670. This would be 2670. Add those two up. The total of that, whatever 2670 times 2 is, 5340. 5340. Now that's much less area than the other plan. The other plan gave over 8,000. This is just 5,340. So see, it makes a big difference. In both cases, we're using all 480 feet of fencing. If you add up 26.7, 26.7, 26.7, 100, 100, 100, 100, you'll get 480 feet of fencing. Same thing here, 82.5, 4 times and 50, 50, 50, you'll also get 480 feet of fencing. My point is, depending on how we build this thing, we're going to use all the fencing, but we could get very different amounts of area inside. So the question is, the real life question is, which way should we build it to make the most maximum area? All right, well, having fooled around, I just want to give you a feel. Let's dive in. How do you actually solve these? Well, let me go back and draw us a new one. Okay, so what we need to do is just call this x, and x, and x, and x, because we don't know what that dimension should be, and y, y for the other one. You just make up a variable. Okay, and now we're going to end up having two equations. One of them is the total feet of fencing. So 480 feet of fencing is 4x and 3y. You see that? X, 4 x's, and 3 y's. Add all those up. That's all the fencing, isn't it? It's all the fencing is 480. So that's our first equation. And then comes the second equation, the one that we're trying to maximize. What are we trying to maximize here? Area. Area inside. What is the area inside? Well, the area of this part is x times y, right? The area of a rectangle is x times y. And the area of this rectangle is also x times y. So the total area is xy plus xy, or 2xy. So we're trying to maximize the area, and the area formula is 2xy. So how do we go about doing this? So step one, solve for y, and we're going to plug it into the other one. So solve this equation for y. So if we come to this equation and we subtract 4x from both sides, we will get 480 minus 4x is 3y. And then we divide through by 3. We will get 160 minus 4/3 x is y. These cancel. So we got y alone. That's step one. Step two, plug y equals 160 minus 4/3 x into the max equation right there for y, because we want to get the max equation to only have one letter. So what do we have now? The area is 2x times y, and what is y? It's this, 160 minus 4/3 x. So there's our area formula. Let's distribute that. We're going to get, what's that going to be? 320x minus 8/3 x squared, right? Because it's 2 over 1. That 2 goes to the 4, and the 1 goes to the 3. Okay, so that's our area formula. Now, let's, we're trying to maximize that area formula. Let's rewrite it. I like to put the x squared term first. Just easier, I think. You don't have to, but I think it'll help you. Help you to see what you need to see. Here, let me write that a little better. Okay, so we're trying to maximize that formula. How do we maximize that? Well, what is the graph of that thing? If we were to graph it, let me graph a little better than that. If we were to graph it, do you know what the graph would look like? What is that? That's a parabola. It's a U shape, and there's a negative in the front, so that means it's going down. So it's some kind of a parabola like this, and its maximum is going to be right there at its vertex, isn't it? So really, when they're saying find the maximum area, they're saying find the vertex. X equals, and what's the formula for the vertex, for the center of a parabola, the highest point on a parabola that goes down? It's negative b over 2a. Very important formula to know and have with you on the exam. So how do we find, what's the b and the a? Well, this is the a. A is whatever's next to x squared. This is the b. Remember, a and b, whoops, that was kind of scribbly. A and b are the numbers in front of x squared and x. So then this becomes x equals negative, get the negative form of that from b, which is 320 over 2 times a. A is negative 8/3. So what happens here? Well, right away you can just cancel these two negatives, right? These two negatives just make positive. And what can we do? We'll take 320 over. Now this is 2 over 1, so the 2 multiplies the 8, and the 1 multiplies the 3. So you get 16/3. Now this is x equals, what do you do when you have a fraction in the bottom of a fraction? You flip it upside down. Are you aware of that trick? Why do we do that? Because division is upside down multiplication. I think you know that. So if you take 100 and you divide by 2, we all know that's 50, right? What if you take 100 times a half? What's half of 100? Same thing. Do you see how dividing by 2 is the same as multiplying by the upside down of 2? I think you already know that. Dividing and multiplying are just upside downs of each other. Therefore, if we're taking 320 and dividing by 16/3, it's the same thing as multiplying by the upside down, 3/16. So now you just use your calculator on that. I think I'll do it by hand. Put this over 1. 16 goes into 32. 2 times 20 times 3, 60. So x is 60. So I've got x. That's the x value of my parabola. How do I get now the y value? Well, you go back up and grab the formula. We had it right there. Y is 160 minus 4/3 x. So y is 160 minus 4/3 x. Plug in that x right there, and you get 160 minus 4/3 times 60. This is over 1. 3 goes into 60 20 times. 20 times 4, 80. So y is 80. So that means that x should be 60 and y should be 80 for maximum. So that means x here should be 60. All these x's should be 60. And all the y's should be 80. That's the way the rancher should build the corral so as to make it have maximum area. What is that, by the way? 60 times 80? That's 4,800 for each of these, right? 6 times 8 is 48. Add the 2 zeros. And so the total of 4,800 times 2 is, isn't it 9,600? I'm kind of scribbly there. 9,600. That is more than we got here. 8,000. That was pretty good, but 9,600 is even better. See how this is better? Well, what is the greatest possible area? 9,600. I cut that by x times y, 4,800, and x times y, 4,800, and I added those together for a total of 9,600. The shorter side is the 80. This is the shorter side. Shorter side of the whole rectangle. And the longer side of the whole rectangle, both parts. That means this longer side up here. This is the longer. That's 2x, 60 and 60. That's 120. He should build the rectangle like that. 80 on one side, 120 across the top, 60, 60. And he'll have a area of 9,600. That's the greatest possible area he can have building the corral like he wants to build it, with a big rectangle with two smaller equal rectangles that are identical. There we go.